Good afternoon everyone. My name is Pushparaj Deshmukh. I am presenting a turbojet engine.
My name is Amar Pawar. What is a turbojet engine? Turbojet engine is a typically breathing jet engine. It is a commonly produced the thrust exploring high velocity exhaust gases. Common used in aircraft, military jets, and operates on the Brayton cycles. These are the major component of the major component of the turbojet engine. The first is air intake. Take airflow to atmosphere and slow down while increasing pressure before it is entered the compressor. Second is the compressor incoming air to the high pressure, improving the combustion efficiency. Third is combustion chamber. Combustion chamber. The fuel is injected into the compressed air and burned continuously produce high temperature gases. Fourth is a turbine. They extract the energy from the hot gases and drive the compressor through the shaft. Fifth, the nozzle. The nozzle acceleration of exhaust gases to high velocity producing the thrust.
Here is the working of the turbojet engine. मी जिथं थांबल ना तिथं फक्त ती पॉज कर. Video the working of the turbojet engine. The operation of the turbojet engine is continuously dynamic cycle that can be broken down into the above four primary stages. Air intake. Air enters the engine through the inlet where its speed is reduced and pressure is increased. Third is compression. The compression the air to the high pressure. Combustion. Combustion is the process fuel is ejected into the compressor air in the combustion chamber and burns continuously. Exhaust. The hot high energy gases expands and rotates the turbine which drives the compression. The remaining gas exits through the nozzle at the very high velocity, reduce the thrust around the Newton's third law.
According to the Reynolds cycle.
काय पूर्ण वाचलं एवढंच ह्याच्या मागची पण slide. What does the turbojet engine needs to work efficiently? Advanced material. What are the advanced material? The extreme temperature within a turbojet requires material capable of immense heat resistance. Super alloys such as nickel-based icon layer are essential for the critical components like turbine blades, prevents melting and deformation. Reliable fuel system. A consistent and final atomized supply of fuel is created critical for stable and efficient combustion. The fuel delivers an ignition system must operate flamelessly to maintain the continuous burning process. Precision engineering. The aerodynamic design of the compressor and the turbine blades is paramount. They must be engineered with the incredible precision to maximum airflow, minimum drag, and ensure durability under high rotation speed and thermal stress, effective cooling and lubrication. To prevent catastrophic failure, complex cooling system protects components from extreme heat, often using internal air passing lubricants system are equally vital to reduce friction and barriers on the rotation.
The advantages of turbojet engine. The first is high speed performance. Second is a simple design. Third is a continuous thrust. The fourth is a high altitude efficiency. Fifth is a lightweight relative up to the thrust. Sixth is the reliability. Seven is a component of the fuel is usage at high speed. 8 is a smooth operation. 9 is a quick response, and 10 is a low maintenance. Is a some designs, challenges and limitations. The first is the poor fuel efficiency at a low speed. Turbojet engine the consuming as a lot fuel of a subsonic speed. This is suitable of the commercial long duration of flights. The second is high noise of levels. Exhaust gases is a high speed airflow. Make turbojet is extremely noisy. Requires special noise reduction measure. Propulsion areas. The limitation of thrust at a low speeds. Performance of the best high speeds and produce the best thrust of takeoff the taxiing. Combustion generates the extremely hot gases requiring the special material of the turbine plates. The fifth is the short engine of lift under extreme uses. The components of the typically turbines were faster and continuous high temperature operations.
Pioneering jet fighter iconic. Earlier jet fighters such as the German Messerschmitt Me 262 and the British Gloster Metal were powered by the turbojet engine. These aircraft demonstrate the unprecedented speed and performance capability of the jet propeller during World War II and the earlier Cold War era. High-speed experimental aircraft turbojet continues to the use in some niches applications including high-speed experimental aircraft and specialized vehicles like jets powered drag racers where raw unadulterated thrust is proprietarized over fuel efficiency or noise reduction. Foundation for modern jet engines. All through modern commercial airlines primarily utilize turbofan engines, which builds upon the turbojet design. The turbojet fundamental pivots the way for all subsequent jets. Propellers technicals. Its principle lays the groundwork for innovation in the thrust efficiency and the aircraft designs.
The hard object propulsion. The first is the core function. The core function is the turbojet engine is a masterfully convert to air fuel and into the powerful forward thrust using a precise sequence of the compression, combustion and expansion. Propel aircraft at high speeds. The historical legacy. The understanding the turbojet engine reveals the engineers engineering behind high-speed flight. Historic legacy. The understanding the turbojet engine reveals the engineers engineering behind the high-speed flight and highlights their foundational role. The evaluating the modern aviation. The turbojet engine is the design of delicate balance, managing extreme heat, achieving the incredible speeds, maintaining the precious machines, pushing the limit and material machines and aerodynamics
of the turbojet engine. Thrust is a force that is useful to force the aeroplane in the air in the front. So let's explain the Brayton cycle. The Brayton cycle is a thermodynamic cycle and that describes the working of gas turbine engine, and it consists of four main processes that transform heat into mechanical. So there are four stages in the Brayton cycle. First is isentropic compression or compressor. The isentropic compression means the isentropic compression. The compression helps the compression. So ambient air is brought into the compressor. Ambient air is brought into the compressor. Work is done on the air, significantly increasing its pressure and temperature while keeping entropy constant in ideal cycle. Means in ideal cycle, the work is done in the air significantly increases, and that time pressure and temperature while keeping entropy it is constant. Then next is combustion. Constant pressure heat addition. In combustion combustion type means constant pressure heat addition is required. So compressed air enters the combustion chamber. Means in the combustion chamber, compressed air is entered time. Fuel is added and that ignites the fuel and create a sparking ignite and then fuel is burned. That time this occurs constant pressure causing a massive increase in temperature and volume is increased. So the in combustion constant pressure heat added. Then next is isentropic expansion. In expansion section, turbine is section is it. So that turbine section also called as isentropic expansion. The high volume gas expands through the turbine and turbine gas, and the gas does work on the turbine, which drives the compressor or and its pressure and temperature decrease. Means that in expansion section, turbine section, the pressure and temperature is decreased. Then next is constant pressure heat rejection, means the exhaust transfer section. That this section, the pressure heat are constant and rejection. The remaining hot gases are exhausted into the atmosphere in open cycle like a jet engine or any engine. Fresh air is pulled into the restart. Restart the process effectively rejecting heat to the surrounding at constant pressure. Means in the expansion, in the exhaust section, the pressure heat are rejected at constant. So this is the Brayton cycle, and this is the graph. So this is the pressure and this is volume. The pressure will increase and volume will decrease. So this is the Brayton cycle. So first is isentropic compression. This is the isentropic compression compressor working that shows. This is the exhaust nozzle. This is the air intake, and this is the compressor section, combustion section, and this is the turbine section. Constant pressure, heat addition, combustion, and isentropic drive expression. Constant pressure, heat addition. They will show in this slide. The next, so this is the thrust equation. The thrust equation is m dot bracket v minus v naught plus pe minus p naught a. So the m naught is the mass flow rate of air, v is its jet velocity, v naught is the flight velocity, and nozzle pressure was ambient, significant at high speed low altitude, and pressure thrust velocity is traced. And this is a movement source, change in the air, momentum thrust source, momentum thrust will calculate it. So this is. Then next. So next slide is a factors affecting thrust, air density, ambient temperature, altitude, flight speed, drag. So what is air density? The direct impact on the mass flow of air entering the engine is called as air density. The next is ambient temperature. What is ambient temperature? The denser cold air produces more thrust than less dense warm air called as ambient temperature. The next is altitude. What is altitude? The thrust decreases as altitude increases due to volume air, pressure and density called as altitude. The next is flight speed parameter. So what is flight parameter? Higher speed increases intake pressure and but decreases the velocity differential called as the flight speed. The next factors affecting thrust. Second point is RPM, engine RPM. So what is engine RPM? What is RPM? Revolution per minute. Higher rotational speed increases the volume of air processed and compressed. What is the engine RPM? The next is turbine inlet temperature. Turbine inlet temperature is higher combustion temperature increases the energy available for exhaust velocity. Then next is humidity. Humidity, high moisture content slightly reduces air density, marginally lowering thrust. Then next is nozzle design. So nozzle design is efficiency in converting internal pressure into high speed exhaust flow. The next is, so this is the factors affecting jet engine thrust. We'll show you this in this slide. There is the moisture, thrust, the pressure and effect, flight speed, air density, air temperature, turbine temperature, humidity, all etc. Then next, so next is types of gas turbines. So there are four types of turbines, turbojet engine, turboprop, turboshaft, and turbofan. So let's come to first turbojet engine. So this is the turbojet engine. This is the inlet gallery. This is the compressor section. This is the combustion chamber, fuel injector that injects the fuel and they helps to the burn the fuel. Then next is turbine section. This is high pressure turbine, exhaust nozzle, and this is the low pressure compressor, high pressure compressor. This is the cold section of the compressor section and hot section of the combustion and exhaust section. Then let's come to the turboprop engine section. So the in turboprop engine, one more difference is the in turboprop when inlet section is propeller has present. The propeller, this is the propeller. This is a low pressure compressor, high pressure compressor, cold section. This is the hot section of the combustion and exhaust section, fuel injector, combustion chamber, turbine, nozzles. Then let's come to the turboshaft section, turboshaft engine. So the turboshaft engine is used for only like turboshaft engines. So turboshaft engine is used in aviation or helicopter system. So turboprop is used for commercial private jets and the turboshaft engine is used for helicopters, choppers. So this is the intake section, compressor, gas pressure turbine section, and fuel, etc. All the same like that. And this is the turbofan engine. The turbofan engine is used commercial aircraft purpose because in this section turbofan are attached from the intake section. This is the bypass here passes through the compressor section and they pull the air section and then pass the air to the combustion section. Fuel injected that time, fuel and air mixed and burn the fuel. And that time, air fuel mixture more thrust generated, more vapor generated, high pressure vapor generated and pass to the turbine section. The turbine section passes to the exhaust nozzle section. So this is the high pressure turbine section is here. Compressor turbines, nozzles, and this is the gearbox. This is not okay. So this is the turboshaft engine. This is turbofan engine, turboprop engine, turbojet engine. Then next. So let's come to the ramjet engine section. The ramjet engine. Usually the ramjet engine used in the missiles. So how ramjet engine works? Inlet compression, combustion and exhaust. High speed air enters the inlet and is slow down as the degrades and its dynamic pressure is converted into the static pressure. Its dynamic pressure converted into the static pressure that ram effect generates. Then next is combustion. Fuel is injected in compression section. Fuel injected at that time. Pressure rise the stream and ignite in the combustion chamber, and it is create more power, more pressure, and to pass the exhaust section. The hot expanding gases are expelled through the exhaust section. A nozzle at supersonic speed. The nozzle speed is a supersonic speed, and then creating a thrust. No compressor works efficiently at supersonic speeds. Compression energy while that create ramming effect. That's called as ramming effect. There are the characteristics: no static thrust, high speed efficiency, simplicity. There are some characteristics. So this is the ram rating. This is another. This is exhaust section. This is the main side of the section. Fuel injector, combustion chamber, nozzle, cold section, hot section. Then let's come to the scramjet engine. So scramjet engine combustion fuel injector used in hypersonic vehicles. Means hypersonic vehicles and missiles are specially used in scramjet engine. Scramjet engine means supersonic ram jet engine, called as scram, supersonic combustion engine, supersonic ram jet engine, supersonic. The scramjet engine, supersonic combustion ramjet, called as scramjet, is a variant of ramjet engine designed to operate hypersonic speed and practically above Mach 5. Unlike traditional jet engines, it has no moving parts and maintains the supersonic airflow through the entire combustion process. Then next, how scramjet engine works. So the operation of scramjet engine is defined by four main stages. There are the four stages. First, supersonic inlet. Supersonic inlet works like as a high speed wave enters the engine at hypersonic speed, and the shape of the inlet uses a shock waves to compress the air and without the need for mechanical compressor jets. Then next is isolator. The isolator section manages the high pressure shocks. High pressure shock it manages, and high pressure shock waves created by the combustion preventing them from traveling. That time back out front of the engine, which will cause the engine and start. And then next is supersonic combustion. Means it is like a combustion chamber, like that. Supersonic combustion, it works as a fuel is injected into the airstream, but it is still moving supersonic speed. Combustion occurs incredibly fast, often compared to the lightning to Mach events. Then next is nozzle. High pressure exhaust gases through the expands in the nozzle, means high pressure exhaust gases expands in the nozzle, and that time the back-to-back produce massive amount of thrust. Means the nozzle massive amount of thrust produce. The purpose of that intake is jet engine is critical component designed to manage the airflow before the reaches the compressor. It's primarily for the purpose of depending on the flight speed, but the core objectives remain the same. Efficient air delivery, mass flow uniformity. There are those purposes of that. These. The intake must supply the engine with the. Then next is efficient air delivery, mass flow. The intake must supply the engine with the required mass flow of air to produce thrust constantly across various flight conditions. Flow uniformity. It ensures that the air reaching the compressor is as uniform and steady as possible to prevent engine stalls or surges. This is the jet engine intake function and objectives. This is a subsonic flight and this is a supersonic flight working and purpose will show you engaging, diverging, the treating, receptive, ram pressure gauge, then only shock wheels, compressor ram, airflow supersonic, then normal shock, manages shock and the slow air. It manages the shocks and converting to slow air slowly and increases pressure. That is the purpose of that subsonic and supersonic index. So let's come to subsonic index. Subsonic index, how it works? The subsonic index works as a thermometer between the passage gets bigger as the air moves further into the engine. Subsonic index or index, that's mentioned in that. deceleration. As air enters the body, its velocity increases. At time, means the velocity decreases, at time deceleration happens. Pressure recovery and diffusion. Bernoulli's principle states that as the velocity of the air drops, its static pressure increases. This is often called as a rapid pressure recovery, and diffusion means this process of slowing the air to convert kinetic energy into pressure is known as the diffusion. Means the diffusion is said as the process slowing the air converting to kinetic energy into pressure called as a diffusion. By the time the air reaches the first stage of the compressor, it is moving at a steady, manageable speed, usually around 0.4 to 0.5 to prevent the compressor blade from stalling. Then next, this is a subsonic effect. How it works will be mentioned in this image. Inlet this is an inlet coming average under prime pressure compressor. Exit is average pressure is higher and air flows witness. Inlet there are these air compressors and slows air speed increases, static pressure or increases compression. Supersonic index, same as that index. The physics of shock waves unlike subsonic index that use a simple winding shape. Supersonic index uses shock waves to crush and clear the air. So what is oblique shock waves? Oblique shock waves means oblique shock waves, normal shock waves, subsonic diffusion. So there are the supersonic index states. RAM, subsonic load compressor, supersonic air flow, optic shock waves, normal shock waves. So oblique shock waves, so supersonic index, oblique shock waves. What is oblique shock waves? As supersonic index heats a physical feature of the index like a spine or a ram. It creates oblique angled shock waves. These waves reduce the air speed slightly and increase its pressure by keeping its supersonic body oblique shock wave. The next is normal shock wave. Normal shock wave, the air eventually passes through final normal shock wave perpendicular to the flow. Means perpendicular to the flow. This wave distantly drops the air to subsonic speed and significantly boosts the static pressure. Then next, subsonic diffusion. What is subsonic diffusion? Once the air is subsonic, the inlet acts like a stabilizer to stabilize the flow and increase the pressure before it enters the compressor. That is the subsonic diffusion. We'll mention it in the diagrams. Compressor functions, core functions, temperature, air supply, rotors, stators. There are many points are mentioned. So this is the jet compression function and operations. Rotors. The rotors are fixed into the fixture. Added velocity. They added the velocity and convert kinetic energy. And stators. They convert to pressure deceleration. These are fixed into the section. This is the static pressure part, and this is the compression stages are mentioned in this graph. Airspeed, increase airspeed, and temperature for efficient combustion. So let's come to the centrifugal compressor. So centrifugal compressor, also known as radial compressor, works by accelerating air output from the center to the edges of spinning wheel. It's highly rushed and capable of high pressure just in a single stage. There are three stages: inlet, the impeller, and accelerator. So first inlet, the air enters into the compressor through the center of the spinning impeller at this point called as the inlet works. Then next impeller. The impeller is a high-speed spinning disc with curved blades. As it rotates, uses as it rotates and it uses the centrifugal force generated and filling the air outward toward the ring. And next is centrifugal compression. This is the result, and so the result is the air gets maximum amount of kinetic energy velocity. The air is moving relatively slowly and with low pressure. Then next is the diffuser. The diffuser works in the diffuser means the converter. Once the air leaves the impeller, it enters the stationary section of the diffuser. The diffuser has winding shape that causes the air to slow down. This is the diffuser result. Barber principle states that as the air slows the kinetic energy and is converted into the static pressure, this is the where the actual compression happens. Centrifugal compression, function and operations are mentioned in this slide. Rotor side, velocity, kinetic energy, inlet airflow, impeller high velocity, impeller high velocity, velocity, diffuser pressure, executive combustor. We'll mention in this air speed, static pressure versus engines. This is the air intakes and passes through the sections. Let's come to the axial compressor. So axial compression works by moving air parallel to the axis rotation straight through the engine. It is the most common type of compressor. It is used in large jet engines and gas turbines because its high efficiency and ability to handle the massive volumes of air is very great. So how it works? The push and slow means it works like a push and slowly. Method and axial compression consist of multiple stages. Each stage is made of two specific type of blades. First is rotor, called as spinning blades. These are attached to the central shaft and it helps to the compressor spin very high speed. Then next, axial compression. Then this is the function like the axe like the function is the means the blade the axe like and accelerating the air and giving its high kinetic energy velocity. Status, second type of the blades, stationary. They are fixed into the outer casing of outer casing and do not move. They are not used, only protect the casing. Function, they act as a diffuser because their shape they slowly keep the air down. According to the Bernoulli's principle states that the velocity increases, the static pressure increases. Means the velocity decreases, static increases. Axial compression of it works we mentioned in this image. Rotor rotating blades. There are the rotor rotating blades. Stationary vanes and pressure increases, airflow decreases. We will mention in this image. This is the airflow direction. Multiple stages add velocity and convert to the pressure creating high compression. There are the compressor performance parameters, pressure ratio, low speed, high speed, isotopic efficiency, reality. Low speed ratio is lower ratio, high speed is modern axial compressor, can reach it to 40:1 or higher. Isotopic efficiency is magnetic. This measures how close the compressor comes to perfect compression without wasting energy as heat. Reality is the real compressor are generate functions and turbulence. Mostly high performance compressor operates 85% to 92% efficiency. And the pressure ratio, this ratio of the air pressure existing in the compressor to exceed the air pressure in the inlet. Compressor performance parameters, corrected mass flow and stall surge margin. There are mentioned in this. The amount of air is calculated in kg per second, kg per days. Then this is a safety gap between the carbon operating point and surge line. Pressure goods much further air can backward to the compressor surge. So compressor performance parameters they works like how it works. So the compressor back engineers Use a compressor map to visualize the parameters, which is a graph that plots the pressure ratio against the mass flow, surge line, operating line, efficiency items. The upper limit of map crossing this line causes the engine backfire or stall. Operating line means the engine throttle takes as you throttle from idle to full power. Efficiency items certain the regions on the map to keep the engine operating the running through the center of the items for maximum fuel economy. So we mentioned the graph. So first pressure ratio versus mass flow. We mentioned it. This is the pressure ratio, speed, revolution per minute, surge line. We mentioned it, and this is the efficiency mass flow. We mentioned it. Correct mass flow efficiency. So strong margin 80% RPM, 90% RPM. We mentioned it. Compression performance parameters. The